What's it like being such a big celebrity? Everywhere you go, you're surrounded by fans who just adore you. The glamour, the fame, the adoring fans. Your life sounds like such a blast. Wait, what? You're saying you're not a celebrity? That's not your life at all? Well, maybe not in this world, but hey, there's a reality where you are living that A-list life. Thanks to the many worlds theory, every possibility exists in parallel realities. So, somewhere out there you're a rock star. Or a Nobel Prize-winning scientist curing diseases like cancer. Maybe you're a best-selling author whose novel captivates the world. Now, you might think this sounds like something straight out of a sci-fi flick, but guess what? It's not just a fantastical idea. This idea is deeply rooted in ancient cosmology and is a serious scientific theory that researchers are investigating today. Intrigued? Let's dive into the fascinating exploration of parallel universes. The idea of parallel universes might be new and unsettling to scientists, but it's not new. In the 5th century BC, Greek philosophers known as atomists proposed that everything in the universe is made up of tiny particles called atoms, which are constantly moving around in an endless empty space. When these atoms collide, they come together to form everything we see around us, like trees, rocks, water, and even the universe. Crucially, the atomists believed there were infinite atoms, which means there could be endless combinations of them, leading to the idea of infinite worlds. Even predating the Greek philosophers, Indian cosmology described many different realms, ranging from the earthly realm ruled by mortal kings to celestial planes ruled by divine entities known as gods. Within this framework, the gods themselves inhabit diverse worlds and planes of existence, each with its unique features and inhabitants. Additionally, the Puranas also talks about how the universe goes through the cycles of creation, preservation, and destruction, hinting at the existence of multiple realities evolving over vast cosmic times. This concept resonates with modern cosmological theories, where our observable universe spans about 93 billion light-years. So, if you travel at the speed of light, it will take you an unfathomable 93 billion years to go from one side to the other. That distance is almost incomprehensible. But that's just the universe that we can see. What's beyond that? Well, nobody really knows. It's possible that the entire universe is infinite. And if that's true, then there's a possibility that countless other universes could exist alongside ours. And if that's true, there's a possibility that some of these universes are exactly like ours. It's like the famous infinite monkey theorem. If you give a monkey a typewriter and enough time, eventually the monkey could type the complete works of Shakespeare. Purely by chance, of course. While the probability of this happening is incredibly slim, it's not zero. So, if the universe is infinite, then somewhere out there, there's a solar system with the sun like ours, an exact copy of Earth and an exact copy of you. Another way multiverses could exist is explained by the bubble universe theory. If the Big Bang created the universe, where did the Big Bang happen? This rapid expansion of the universe from a tiny speck of energy implies that our observable universe is only a tiny portion of a much larger space, potentially an infinite space. And if the universe is truly infinite, then there's a possibility that there have been countless Big Bangs occurring throughout this vast expanse. Each Big Bang could have given rise to its own universe, akin to bubbles floating around in space. These universes may emerge and evolve independently, existing along our own but beyond our current observational reach. The Yoga Vasistha, an ancient Indian spiritual text, says that while you can count the rays of the sun, you cannot count the number of universes that exist. This means there could be universes where the laws of physics are different from ours. For example, the speed of light might change or gravity might work differently. Even within our own universe, there are places like the quantum realm, which is so tiny that it's smaller than atoms, where our usual understanding of physics doesn't apply. Here, particles can instantly communicate over vast distances, defying the speed of light, and can exist in multiple places at once. This strange behavior suggests that if particles can act this way, maybe entire universes can too. This leads to an interesting theory about parallel universes. The idea that there are infinite copies of our reality, not spread out across distant spaces or floating in cosmic bubbles, but existing simultaneously in different dimensions. Now, the question is, how is it possible for parallel universe to coexist? The many worlds interpretation of quantum mechanics offers a fascinating perspective on this mystery. According to this theory, every possible outcome of a quantum event actually occurs, each in its own separate branch of reality. In simpler terms, when something uncertain happens at the quantum level, like the state of an atom changing, instead of just one outcome happening, all possible outcomes happen, each in its own universe. Think of it like the butterfly effect, where small changes can ripple out into significant consequences over time. Think about the comet that wiped out dinosaurs. It came from a distant part of our solar system. If you could go back to its starting place, millions of years ago, and altered its trajectory by just a few inches, by the time it reaches Earth, it would be so off course that it wouldn't hit the planet. This small change millions of years ago would have completely reshaped the entire history on our planet. So, there's a universe where dinosaurs didn't die. Instead, they evolved into intelligent beings, ruling a world where humans are the ones struggling to survive. In the same way, the principle applies to our lives as well. Consider your own existence. What if your grandparents hadn't met each other? In such scenario, you might not even exist today. And it's not just big moments like this that matter. Even the smallest decisions we make in our daily lives can have a big impact. Take, for instance, choosing what to eat at a restaurant. It may seem insignificant at that moment, but that choice could determine whether you enjoy a delicious meal or end up sick from food poisoning. As scientists delved deeper into quantum physics, they stumbled upon some puzzling mysteries, one of which is called the observer problem. In the famous double-slit experiment, electrons behave like waves, creating an interference pattern on a screen. But when observed with a detector, the interference pattern disappears, leaving behind only two narrow strips. The mere act of observing the electron appears to alter the electron's state. But why? Why does observing something alter its state? To answer this, Danish physicist Niels Bohr proposed that quantum particles doesn't exist in one state or another, but in all of its possible states at once. It's only when we observe its state, it is forced to choose one probability, and that's the state that we observe. Imagine a coin spinning in the air. It exists in a state of uncertainty, where it could be both, heads and tails. Only when it lands and you look at it, it collapses into a single outcome, either heads or tails. But not everyone agreed with the idea that a particle could exist in all possible states at once. Hugh Everett III came along with a fresh take. Every time a quantum event occurs, instead of the universe collapsing into a single outcome, the universe branches into multiple parallel realities, with each branch representing a different outcome of that event. This means that for each quantum event with multiple possibilities, there are multiple realities. If this is true, where are these parallel realities? The multiverse theory says parallel universes could be right here, right beside us, in the very same space we occupy. But because we are creatures bound to perceive only the dimensions of three-dimensional world, we remain unaware of their presence. In your living room alone, there exist infinite versions of yourself engaged in various activities. Some watching TV, others reading a book, or even building a time machine. But there are also parallel realities where your living room doesn't exist because life on Earth never developed. So, is it possible for us to ever visit these parallel universes? Even Hugh Everett, who proposed the idea of parallel universes, believed we couldn't directly access them. But new experiments are attempting to change that. Scientists at places like CERN and Fermilab are using particle accelerators to study the basic building blocks of nature by accelerating protons and smashing them together. One area they're exploring is gravity, searching for tiny particles called gravitons, which could reveal the existence of extra dimensions. But detecting gravitons is incredibly challenging and may require extensive experimentation over many years. Well, theoretically, a wormhole could connect two distant parts of the same universe, or even different universes. Predicted by the theory of general relativity, they are thought to be essentially a tunnel from one place to another in space. But until now, there's been no direct evidence of their existence. Even if we find them, they bring with them the dangers of sudden collapse, high radiation, and dangerous contact with exotic matter. Additionally, there's the issue of time dilation. In regions of higher gravity, time passes more slowly. This means that if you were ever able to journey through a wormhole, your journey might be just a fraction of a second for you, but thousands of years could pass on Earth. So, while traveling through a wormhole is theoretically possible, it's not currently considered practical or feasible. Nevertheless, there may be other ways to catch glimpses of alternate realities without relying on wormholes. Take, for instance, the Mandela effect, a phenomenon where many people collectively remember events or details differently from how they actually happened. Named after the widely shared false memory of Nelson Mandela's death in prison during the 1980s, despite his actual release in 1990 and passing in 2013. It highlights how our memories can sometimes diverge from current reality. Another example is the misconception that the Monopoly man wears a monocle, even though he never did. Usually, we explain these false memories as mistakes in our brains or the influence of popular culture. But some suggest a more intriguing possibility: parallel universes intersecting with our own. This means that our false memories might actually be recollection from other realities where things happened differently. Some even propose that phenomena like déjà vu could be glimpses of experiences from other realities where we momentarily connect with versions of ourselves who lived through those events. In Hindu philosophy, the concept of Maya, or illusion, posits that the reality that we perceive is not the only reality. According to the Vedanta school, Maya is the cosmic illusion that presents the physical world as the ultimate reality, while in truth, it is a deceptive veneer that obscures the true nature of existence. This idea is prominently discussed in the Upanishads and the Bhagavad Gita, aligning with the idea of multiple realities that we are not typically aware of. This concept challenges the conventional Western view of time as a linear progression from past, through the present, and to the future. In contrast, Hindu cosmology presents time as cyclical, characterized by repetitive cycles of creation, preservation, and destruction. This cyclical view suggests a form of cosmic repetition, where events and experiences recur across different cycles of time. It raises the intriguing possibility that parallel universes, rather than existing as distinct entities, may instead be interconnected through the cyclical rhythms of time. Moreover, influential figures in theoretical physics, such as Nikolai Kozyrev and Hugh Everett, have proposed ideas that further challenge traditional views of time and reality. Kozyrev suggested that time doesn't follow a structure at all. There's no past, present, or future. Instead, all the events that we call past, present, or future occur simultaneously across different dimensions that lie beyond human perception. In other words, all moments in time exist simultaneously, like multiple layers of reality stacked on top of each other. Everett's many worlds interpretation of quantum mechanics complements this view by proposing that every decision creates a branching of reality, leading to the creation of separate universes for each possible outcome. So, every choice you've ever made, big or small, like turning left or right at an intersection, creates a new universe. There's a universe where you turned left and another where you turned right. With each decision, A whole new universe springs into existence, exploring different paths of possibilities. Who you are at this moment is the result of thousands of choices you've made throughout your life. So, somewhere out there, there's a reality where you made the right combination of choices and became a superstar, a Nobel Prize-winning scientist, or a best-selling author. But remember, if you're happy with your life, even if it's not perfect, you've made good choices and be satisfied with that. And if you're not happy with your life, don't dwell on the past and the mistakes you have made and what could have been. Because until your life is over, you'll have the opportunity to make a lot more choices. And every time you have to make a decision, whether a big one or a small one, think about this video and the butterfly effect. Thank you so much for joining me on this exploration. If you had fun or learned anything, I've got a humble request. Please like, subscribe, comment, and share. I might not be certain about other realities, but I'm sure your support matters in this one. Until next time, keep wondering, keep pondering, and know that you are appreciated. Cheers!